Hello students, welcome back to the part 3 of Discrete Mathematics. In this video, we are going to discuss the types of sets, null set, finite set, infinite set, equivalent set, equal sets, subsets and power set. So let us start with the first one, which is a finite set. A finite set is a set that contains a finite number of elements. For example, the set of natural numbers less than 10 is a finite set. We can say that the cardinality of the set is finite number. Example 2, the number of letters in the word mathematics. We can count the number and that is a finite number. The cardinality of the finite set is a finite number. Infinite set. An infinite set is a set that contains an infinite number of elements that may be countable or uncountable. In the example 1, the set of all natural numbers is an example of an infinite set which is countable. And in the example 2, a set of all points on a line minus infinity to infinity is an example of the infinite set. Of course, this is the set of real numbers in which we have uncountable members. So, depending upon that, the infinite sets can be said to be infinite countable if its elements can be placed in one-to-one correspondence with the natural number. So we have set of integers, set of all even numbers, or set of all rational numbers as infinite countable set. The uncountable set is an infinite set that cannot be placed in one-to-one correspondence with the natural number. The set of real number is an example of uncountable set. In the example 2, the open interval 0 to 1 is also an example of uncountable since we cannot count all the members of the set, or the cardinality of the set is not finite set. As we can see, the singleton set, it is also known as a unit set and it contains exactly one element. That means the cardinality of the set is 1. For example, a singleton 5 or V, where V is a vowel and first alphabet of the English. So set B contains just a single element A and therefore the cardinality is 1. In the example number 3, we are going to consider a number x from the natural numbers such that x cube is 27. So if you think, then what is the natural number whose cube is 27? It's nothing but a number 3. The set C contains a singleton 3. Cardinality is 1 and it is an example of singleton set. The next is the subset. A set A is said to be subset of another set B if every element of A is also an element of B. This is denoted as A subset of B. Example 1. If you consider in real life situation, plants are subset of living things. If you consider students in the class, then it is subset of all the students in the school. Example number 2 is set of all the even numbers is subset of set of all the natural numbers. Example number 3 is a set which contains the letters MATHS is subset of the another which contains all the alphabets which contains mathematics. It is noted that the empty set is subset of the every set and a set itself is a subset of itself. power set. The power set of a set A is denoted as P of A is the set of all possible subsets of a set A, including the empty set and a set itself. For example, if a set A is given as 1, 2, the cardinality is 2, then the power set of A is the empty set phi, the set itself, which is written as curly bracket 1, 2, a singleton 1 and a singleton 2. If you are going to consider the power set of a singleton set which contains only two elements, the empty set and the set itself. The power set contains all possible combinations of the elements from the original set. Its cardinality is 2 raised to n, where n is the number of elements in its original set. So, if a set contains 3 elements, then the power set contains 2 raised to 3, that means total 8 elements, in which we have the empty set, the set itself, the singletons and elements containing 2 elements. So respectively, we can write the power set for a particular set, and the cardinality is also given, which is 2 raised to n. In the next video, we are going to consider operations on the set, union, intersection, complement, difference and symmetric difference. Till then, thank you all.